Hi, I want to introduce myself. I'm Rick Harrison with Rick Harrison Site Design Studio. We're the planners of this beautiful new neighborhood in Gastonia. A little bit about my background. I started land planning neighborhoods in 1968. Then I went off into land development and discovered the importance of engineering and surveying and moved to Texas, where I became a surveying engineering technician for about 4 years. I ended up as head of planning for Dallas's largest consulting firm, Herman Bloom Engineers, in the 1970s when I was 25 years old, and started developing software which Hewlett-Packard had caught wind of. This led to a 2-decade partnership with Hewlett-Packard where we developed and sold engineering and surveying systems to thousands of engineers around the world. By servicing the thousands of users over those times, we had our own aircraft and we were able to look at the patterns of development changing around the country as technology was being used, and saw it was obvious that the land development patterns had become more cookie cutter, because instead of sitting on a table and paper and pen and penciling out these things, all you had to do was press buttons on the computer and voila, you had a cookie cutter site plan in a fraction of the time. Being that we were part of that problem, owning the software company, in the late 80s we formed Rick Harrison Site Design Studio as a research and development arm to use technology to discover new ways to develop land to create better neighborhoods and not just faster plats. Today we have designed over 1,700 neighborhoods in 48 states and 18 countries using the methods that you see on the site plan. This particular method we call coving, in which the homes undulate in and out, creating these coves of open space along the streetscape and eliminating the monotony that's so common to current developments, that every home is at the exact same setback, exact same side yards, the same rear yards. The difference is, in this method, we can actually reduce the length of street, typically around 25% on the developments we work on. This has a massive economic and environmental benefit for the growth of our nation. So what happens when you have 25% on average less street length is now you have a lot more land for the people who live in the neighborhoods, and that's where we get this extra open space that goes into the lots, and why the average lot size is much greater than your typical minimum lot size per your ordinance. Had this been a grid development with much more street length to get that density. So the average distance between homes, front, side, and rear yard, get much greater than the typical gridded suburban neighborhood that would have been proposed before we got involved. The line of sight when you're inside the home and you look out the windows is much greater than a typical development where the homes are all lined up at the exact same setbacks. The only key issue is the 250-foot radius to AASHTO standards. Now, of the 1,750 neighborhoods that we designed, the current typical radius of the roads that we're using is 200 feet. Now, I understand the AASHTO standard of 250 feet because we run into that every once in a while, and that would be about a 30-mile-an-hour speed, which you really don't want in a residential neighborhood. In fact, I live in St. Louis Park. 3 years ago, our snow crew, as they were crossing the street, got hit by a car at 30 miles an hour. After a year, one of them recovered. The other will never recover from that accident. His life is destroyed. St. Louis Park, Minnesota now has a 20-mile-an-hour speed limit that maybe their lives would have been much different had that speed limit been less. And around the nation, you're seeing a lot of cities adopt a 20 to 25 mile an hour residential speed. The 200-foot radius is naturally traffic calming. So in these situations, we asked the city if we could propose a smaller speed limit. And invariably, every city we work in, if it's an issue, grant us that request. I just want to talk a second about traffic flow and what is that? Cars don't go instantly to that 250-foot radius AASHTO 30-mile-an-hour speed. It takes about 200 feet and about this length of time to get up to the 25-mile-an-hour speed, and then it takes about the same amount of time, soccer mom driving, to get back to zero. That's what we call a flow cycle. That's approximately 400 feet. In that 400 feet, it's very inefficient for time and energy. As people drive through our neighborhood versus the proposal before, the drivers maintain a constant speed. So even at a lower speed limit, the average person is going to get to their home on average in less time than the plan before, where most homes would have to stop or near stop, make a 90-degree turn, go up the street, maybe get home, or another 90-degree turn to get home. So when we design these neighborhoods, we want to maintain a constant flow through the neighborhood. And as you can see, the street pattern we're proposing is significantly less street length, not width, but length, than what would have been built in a far more exciting neighborhood to live in, with more space for everybody to enjoy. So the property values increase, meaning the tax base increases, and the maintenance burden to the cities that we design in plummet, which is one of the reasons this new era design has been embraced by every city that we work in. I wanted to thank you for your time and hope this explains what we're really trying to accomplish with this neighborhood.